Cool, I'll just get started. So this is the PCD SDK workshop. I'm doing part 1. My name is Ivan, and I have with me Andrew, who will be doing part 2 of the PCD workshop. Yeah, so to frame this presentation really quick, we're not going to be doing any live coding. We're going to be doing more of like a quick introduction to what we've built. And you can kind of think of it as if we're onboarding you to the team, and we are hoping that you will be an effective contributor. So we will skip over some details that are not super relevant and dive deep into some other specifics. So I'll just get started with that then. So the PCD SDK is actually part of this project that we've been working on that's called ZooPass, which I'm sure all of you have played around with. To you, ZooPass is probably just the website that you have to load in order to get your ticket, to get into PROGCRYPTO, to get into the co-working space, to get into a bunch of other locations around Devconnect. But it's a little bit more than that. So I'm gonna explain exactly what that is by invoking an analogy, or maybe a couple analogies. So when you open up ZooPass, this is what you see. You see your ZooPass identity, and you see a bunch of folders. And when you click into these folders, you see a bunch of these cards that have QR codes. You also see frogs. So what's going on here? Well, one way to think about ZooPass is it's an application that allows you to manage PCDs. So Gmail is an application that allows you to manage emails. You can send emails, receive emails, compose emails. Here's an example of somebody composing an email. PCD is kind of like a file type. It's kind of like email for Gmail, or a Word document for Microsoft Word, or a PDF for Adobe Acrobat Reader, or whatever. So in the same way that Word lets you edit Word documents, it lets you get documents from your insurance, or maybe you're writing a new document to somebody you really hate, or you're just trying to finish some homework. Word lets you edit, view, and create these documents. Same thing for Gmail. So ZooPass is that, but for PCDs. ZooPass lets you get PCDs. It lets you prove PCDs and lets you verify PCDs. So you've got PCDs from Devconnect. Those are your tickets. You also have frog PCDs. Those are just frogs. And you can also create PCDs by yourself. That's a great question. So I will be getting to that immediately next. So going back to ZooPass, and ZooPass lets you manage PCDs. So what exactly is a PCD? So at the most literal level, there is a file in our code base that defines the interface for what a PCD exactly is. So PCD, the PCD stands for proof carrying data. At a high level, a PCD is a piece of self-evident information. It's got a proof and it's got a claim. So the proof you can use to verify the correctness or the truthiness of the claim. So a PCD doesn't necessarily have to like be an object or an instance of anything. It's a more like conceptual idea. So one example of a PCD I like to use to kind of explain the idea is basically I can give you a proof that I know a prime factorization of a number. So the claim would be, I know the prime factorization of 12, and then the proof would be an array of the integers 3 and 4. So that's like a really simple example of a PCD. The PCD SDK is a set of abstractions that lets you encapsulate ideas like this into objects that are portable. And ZooPass is the application that is purposely built around this PCD SDK that lets you manage these PCDs, get them from places, send them to other places, display them, etc. So yeah, any questions about what a PCD is exactly after that description? Yes. Cool. So a PCD is just a piece of information. In order for it to fit into ZooPass and in order for it to fit into the PCD SDK, one actually needs to create a PCD package. So a PCD package is basically a set of code that lets you prove, i.e. instantiate your particular type of PCD, and verify, i.e. check whether the PCD that you got is actually correct. So to show you that, I can actually open up my code editor and I can navigate to a really simple PCD that we've built for Devconnect. It's called EDDSA PCD. So EDDSA is an asymmetric cryptography algorithm that lets you encrypt and sign pieces of information. So an EDDSA signature can be verified to be signed by a particular public key. So here, for example, I am defining an EDDSA PCD. It implements that PCD interface that I showed you earlier, and it's got a claim that is an EDDSA PCD claim and also a proof. So what are these things? The claim is a particular public key and a particular message. And then the proof is the signature, which is represented as a string. So it's pretty simple. Oh, I should just to prove, i.e. instantiate an EDDSA PCD, you call this function, which is exported from this PCD package. And then to verify an instance of an EDDSA PCD, you call verify on this. The way this thing plugs into ZooPass and the PCD SDK is via this object, which is exported from this NPM package and then can be imported anywhere you want. So ZooPass imports this, but for example, if I want to use this EDDSA PCD concept in a third-party application, all I need to do is import this package and then use the prove and verify functions as I please. So we have a bunch of these PCD packages. That's just one of them. So this one is the frog PCD. Every single frog that you have in your ZooPass is actually an instance of an interface that's defined in this package, and we have a bunch of them. Cool. So that's EDDSA PCD. So ZooPass basically lets users store PCDs. It also needs to let you actually do something with them that's interesting. So Gmail lets you send emails to other people. You click a button and like an effect occurs somewhere else in the world. So far, everything we've talked about, all of these PCDs just live in ZooPass and they're not very interesting. So what exactly can you do with ZooPass when you have PCDs in them? Well, ZooPass has an API that lets third-party applications interact with the PCDs that are contained within it. So we have this publicly accessible URL that you can go to, which is kind of like a internal developer tool we use to test the various PCDs and the various like APIs that we've built. I've got that running locally on my computer as well. So I can show you a little bit of some of the examples that are possible to implement with the PCD SDK. Okay, so this is also a local ZooPass. So in this Devconnect folder, I have a ticket. So this thing is actually an instance of a EDDSA ticket PCD, which is basically a JSON object that's signed using EDDSA. So it also has a corresponding PCD package, which has a prove and a verify function. To get this thing into my ZooPass, somebody needed to have called that prove function. And then now I have a an EDDSA ticket PCD that ostensibly one could call verify on and then get back whether or not it's actually correct. So one thing I can do with this EDDSA ticket PCD is ask or give a proof that I have one to a third-party application. So for example, if I click on this and click login, what this is going to do is it's going to, not that one, this one, request ZooPass event ticket proof. So what this is doing is it's navigating the user in a pop-up to a particular URL. So this URL is containing an object, a JSON encoded request that's asking ZooPass for a zero-knowledge proof that I have a ticket. Here I can choose which ticket I want to prove that I have. So here I had the AW internal test ticket. I'm going to choose that one as well. And then here, the ZooPass app is showing that I will be revealing which event and product ID this ticket is for, basically the fact that it's AW and that it is an organizer ticket. And it's not going to be revealing anything else about that ticket. So the ticket has a bunch of other information in it. For example, it has all of this information. So it has the name of the attendee, the email of the attendee, whether this ticket has been consumed, the timestamp that the ticket was signed. None of that information is going to leave ZooPass when I make this proof. The only information that's actually going to leave ZooPass is the event ID and the product ID. So when I click prove, what's actually happening under the hood is ZooPass is generating a Groth16 zero-knowledge proof. There's a circuit that we've written in CIRCOM that Andrew will get into later. And it's going to redirect the user back to this original third-party application. So this third-party application, it gets back an instance, JSON serialized instance, of the zero-knowledge proof that basically proves that I have a ticket to this event. There's some JavaScript on this page that invokes the PCD packages verify function that makes sure that the ticket is correct. So you can see the only fields that are actually revealed to this third-party application are the event ID and the product ID. Everything else is hidden. So that is an example of something that you can do with ZooPass as a third party or as a user interacting with a third-party application. Does anybody have any questions about this? Go ahead. Yeah, that's a good question. So in the Platonic ideal instantiation of the system, ZooPass and third-party applications would be able to pull in these prove and verify functions from the internet. For example, they could live on the blockchain or something like that. In practice, we have a ZooPass monorepo where we have both the server and the client of ZooPass. And then we have a packages directory where we've defined a bunch of these PCD packages, which are NPM packages that export a variable that conforms to that PCD package interface. So ZooPass happens to import a bunch of these different packages. And as a third-party developer, what you can do is import one of these as they're published on NPM and then invoke the prove or verify function anywhere you want. Correct. In practice, if you want to write your own and have that actually work with the ZooPass that we have deployed, you would need to make a pull request into our GitHub repository. Long term, it would be cool if you didn't have to do that, though. Cool. Correct. Yeah, another thing I don't have a slide for, I removed it because I thought it would be a little too much detail, but maybe I'll explain a little bit about where the PCDs actually live. So ZooPass is a web app, but it's a little bit different from Gmail or like Office 365 in that all of the PCDs that you have are actually local storage only, and you can get them onto other devices because you've set a password and we sync them and back them up in an end-to-end encrypted manner. So that API that I showed you, that you get proofs using from ZooPass, lives entirely in the URL, and the API is accessible if you use this pound or like hash character in the URL, and everything after the hash isn't actually sent to the server. That's the way browsers are implemented. So the PCDs live only locally in your devices. That makes sense. Before I move on to a couple of examples of applications that aren't silly little developer demos, I've got two that are live and in production. Does anybody have any questions about what a PCD is, or what a PCD package is, or how an application can interact with ZooPass to get PCDs from it? Does that all make sense?
Good question. You had a tab open earlier with example integrations. Is that published anywhere?
Yes. So it's published on consumer-client.onrender.com. That will give you the production version of this page. One of them is broken. If you find which one, you win, because that means you tried a bunch of them.
We have a QR code with links at the end of the talk, so writing that down so fast.
Yeah, that's a great point. There will be a QR code with many, many links. Okay, so that is sort of a description of ZooPass and PCD abstractly. In practice, there are two use cases that are in production of this stuff. So the first use case is tickets. So I showed you how one can get a proof of a ticket from ZooPass, and I wanted to explain a little bit about how these tickets get into your ZooPass, and in the ideal case, how they might get into one's ZooPass in the future. So to start, I'll talk a little bit about how the tickets get into your ZooPass. So we've got a server that is connected to the ticketing system that Devconnect events, or many Devconnect events, use in order to sell tickets. It's called Pretix. I'm sure all of you got some sort of voucher or were sent a link where you could put in your credit card information and then it would send you a confirmation email that you got a ticket. So that's not us. That's this other application called Pretix. Where we come in is we sync all of the tickets that have been purchased by you guys to our backend. And what we do is when you sign in, we give you a PCD corresponding to the ticket that you purchased. And we don't give it to you just as you have a ticket. We give you an EDDSA ticket PCD, i.e. our server has a private key that we use to sign this ticket information before sending it over to you. So whenever you load ZooPass, you see this brief flash that says loading tickets, right? In production, it's a little bit slower, but what's going on there is the client is asking the server, what PCDs do you have for me? It's not asking what tickets do you have for me, it's asking what PCDs do you have for me? And the server is responding with, here are the PCDs I have for you. So how does the client ask the server for the PCDs? Well, we have this API. It's kind of like experimental. I think we screwed it up a little bit, but it's also pretty cool in some ways. Basically, there's this notion of PCD feeds. We were faced with this problem of we built this cool ZooPass tool, but we had no way of getting a bunch of PCDs into it. So we kind of worked backwards from the end state of how do we get a bunch of PCDs into people's zoo passes so people could actually do stuff with them. So we built this feed API. The idea behind the feed API is we want PCDs to be kind of flying around all over the internet, coming from this place and this place and this place. In practice, they're all coming from us, but we built a general system, as one does as a software engineer. So the feed issuance API basically allows a third-party service to give ZooPass users PCDs if they expose an API endpoint that conforms to like our API specification. Specification is basically the ZooPass app sends a request to the server containing an object that contains a credential PCD. And then the feed API looks at that PCD and does whatever it wants with it, verifies it, and gives you back a bunch of PCDs. So we've kind of, in a sense, like reinvented JWTs in a way. I could go into the code, I probably won't. But anyway, that's how you get tickets, i.e. PCDs, into your ZooPass. And then I don't know if you guys joined the Devconnect or the PROGCRYPTO Telegram group, but the way that you are able to get verified into it is exactly that same API that I showed over here. The difference between how you get into the Telegram group and how you interact with this is that here there's a pop-up. In Telegram, we actually open up the browser that is embedded in Telegram, and it lets you log into ZooPass, which syncs your end-to-end encrypted storage from the server, and then you give the Telegram server, which again in practice is our own server, but ideally in the future could be a third-party thing, ZK ticket PCD, which then calls that verify function in the ZK ticket PCD package, and then lets you into the Telegram channel. So here I have some code I'm not going to go over that generates these credentials that let you ask third-party servers for PCDs. This is what the code looks like on the third-party server end. You can see there's this line, semaphore signature PCD package dot deserialize, and then you validate the credential, which is basically just some code around another one of these PCD package calls. That one would be a .verify. Okay, so that's ticket stuff. Then there's the frog stuff. Again, in practice, the frogs are also coming from us, but in theory, they could be coming from anywhere. Frog server has a PCD issuance feed. You prove who you are to the frog server using a PCD. The frog server then gives you like a soul-bound signed frog, which then you can use again to prove that you have a frog to this frog Telegram server. Cool. All right, so that concludes part one. I am under halfway through our time slot, so I did not do too terribly. Andrew will take over from here and do part two.
Like economics, for example. And I want to know, what was that process like? Were you very involved with the integration? Was it easy? Did they have to make a lot of changes?
That's a good question. So I wasn't personally involved with that process, but I know a little bit about how it works. So fortunately for us, a lot of these third-party events use the same backend as the co-working space. It's Pretix, as I mentioned. So I would basically describe the process as sort of, you know, that image with domino and then a bigger domino and then a bigger domino. So first we went after the co-working space. That took months of back and forth and like deciding on the specification, stuff like that. After we got them, it was about 2 months out from Devconnect. And fortunately, a lot of the third-party events, which in reality are also organized by the EF, just so happen to also use this Pretix backend. And fortunately, the requirements were not super different for them. And as we got people who were willing to experiment, the people who were less willing saw the increasing amount of people who were, and were like maybe FOMOing in or something, stuff like that. Cool.
All right, this working okay? All right, thank you, Ivan. All right, so if we follow our analogy of your new developer on our team getting onboarded, Ivan's the team lead who just gave you the architecture overview and told you what PCDs are and what the product does. I'm the friendly developer sitting next to you who's going to help you, get a little bit deeper and get started on your first project. I'm not going to ask you to actually make a first project today, but hopefully I'll give you enough context that if you want to, you can get started on that. So here's a slightly deeper dive into what Ivan was showing you in the demo. This is the set of PCDs that is involved in your tickets to this event, not in authenticating to the feed server, which is Semaphore, as he mentioned, but just kind of the tickets themselves. So the lowest level PCD, which Ivan showed you very briefly, is EDDSA. That's just a signed message. Its claim is here's a message and here's who signed it, and its proof is the signature of the message. EDDSA ticket is built on top of that. So you have a signed message, which is the ticket itself. And then the EDDSA ticket PCD adds semantic meaning for all of the fields, because the message is just a blob of numbers. And you have to say which one of those is the ticket ID, the event ID, your email, et cetera. And then another layer built on top of that is the ZK proof that Ivan also showed you, which is a proof that you hold a ticket. Without revealing the ticket itself, you can prove that you have one, you can prove that it's properly signed, and then you can selectively reveal some of the fields of it. So I'm going to skip over the first one, which is very simple. The second one is the EDDSA ticket PCD, and I'm going to go show you a little bit of the code of that. Is this code big enough for everyone to read? Should I make it bigger? Okay, make it a little bit bigger. I saw a shaking head. How's that? There we go. That's as big as I can go on this screen, I think. So hopefully it's good. All right, so here's the PCD package for the EDDSA ticket. You can see it contains the various things you can do, most notably the prove and verify functions. It also has the ability to serialize and deserialize a PCD. That's how you get it into storage. That's how you get it across the network. In this case, all of our code is TypeScript, so this is just serializing as JSON. It's pretty simple. But in future, we have thoughts about things like versioning and how to make this format much more simple, much more generalized. It also has some bookkeeping things like the ability to initialize itself and these two functions that are related to how things get rendered inside of our client. These actually return some React code that knows how to render the PCD card that you see in your client with the QR code on it. Also within the type system, there's the claim and the proof. So let me show those briefly. So here's the claim of a ticket. It is just this ticket data, which Ivan showed you briefly before. Contains your event name, ticket name. These are all display fields. It contains the several IDs that define your ticket. And then it has some bookkeeping data like when was your ticket consumed, which means you checked in and you got your badge or your wristband rather. Whether your ticket was revoked, which is something that is supported and you won't be able to scan in anymore if that were to happen. Your name, your email, et cetera. These are all meant to be kind of human readable or at least real human usable fields. How they are represented inside of the signed message is actually each of these is a number. So for instance, let me see if I can find that. That's in the code somewhere. I'll get to it when I get to when I get to proving, which I will do next. Here we go. Go to that one, please. Sorry, not driving my editor fast enough. So here's the function that actually takes that ticket data and turns it into a list of big ints, which is the thing that's going to get signed. Most of these are pretty simple. It's like a UUID is actually a number, so you can just pack it into different size numbers. But things like your email and your name, we're actually hashing it, and that's the thing that's actually getting signed is the hash of that string, just because strings are big. And we want to eventually use these things in a ZK proof where the size of the inputs and the number of constraints is something that we want to be conscious about so that you can do things like on-chain verifiers. All right, so this is our proof function. The first thing we do is we serialize that ticket into that set of numbers. Then we ask another PCD package, that is the EDDSA TCD package, to make another PCD for us. Right, so we're asking for a signed message PCD. The message is the serialized ticket that we just created. The private key is whatever private key we were asked to sign with. And then we can specify what the ID of the resulting PCD is. In this case, we don't care, so we're just letting it be randomly generated. But this is, every PCD does have a unique ID, which is how ZooPass keeps them around and decides whether or not to replace them when you get a new ticket. So that is important there. And then we just pack it all. Once we've gotten this proved by the other PCD package, we can package it all up. Our verify function, similarly, is an example of this PCD is being built on top of another one. So there are two important things that we're doing here. One of them is checking that our actual proof verifies, which in this case, the proof is another PCD. So we ask it to verify itself. What it's going to be doing is checking the signature. But then we also have to check that our claims actually match what the proof says. That's what we're doing here. We're, again, taking our claims, turning them into a message, and then we're checking that that's actually the message that the underlying proof has verified. We'll see that pattern again when we get to the more complicated PCD. Let me go back to the slides for a moment. So that's our first level, reminding you of the levels we're up. That was the EDDSA ticket. The next level up is the ZK proof. So this one actually has a ZK circuit in it rather than just a signature. The technologies we're using here are CIRCOM to generate a Groth16 proof. Inside of our CIRCOM circuit, we're using EDDSA for signatures, Poseidon for hashing, and we have a semaphore identity, which is how you identify yourself to ZooPass. But all of those are choices that are specific to this PCD package. Anyone who makes a new PCD package, you don't have to use these proving schemes or these technologies. You can use whatever you want. The only thing that affects is the dependencies of your app. So if we did some work to try and keep ZooPass from being too hard to download, but if you get more and more proving technologies into it, it's going to get bigger and bigger. That's why we think that eventually this is going to be a set of clients can maybe talking to ZooPass rather than all in one, but we'll get to that later. The claims of this particular proof are somewhat configurable. There's only one CIRCOM circuit, but it has some, if-then equivalents in it that let you claim this. But here's an English version of what the claim is. I have a ticket signed by this issuer containing my semaphore ID, the public commitment of my semaphore ID, and I can optionally prove that its event ID is one of the events in this list, which is an input. That's a way you can avoid revealing which event you attended, but you can say, I attended one of these events who have access to the Devconnect telegram. It also includes a watermark. It also includes a nullifier. I won't get into the details of that, but if you've seen other clever proving schemes, you've probably seen these come up, particularly in semaphore. These are just things you can do, let you do rate limiting, let you avoid replay attacks, let you avoid Sybil attacks, etc. And then you can selectively reveal some or all of the fields of your ticket. That's part of the input. So let me jump back to the code. So here again is a PCD package. It has all the same functions defined. Let's look at, you can see that its claim, I'll show you in a moment, but its proof is just a Groth16 proof. There's nothing else there, that's just a set of numbers. Here's the claim. It's got what we call a partial ticket. This is just a version of that iTicket data that you saw before with some of the fields being undefined. That's because we're only revealing selectively. It contains a watermark. It contains the public key of the signer. It contains that list of valid event IDs. If I choose not to reveal my event ID, but just reveal that it is one of these lists, I can do that. It has the nullifier and the nullifier hash, which is part of that. Let me jump into the prove function. So again, we need to format our inputs in a way that can be used by our underlying cryptography. So we're going to check that our inputs are valid. We're going to format them into the set of inputs that we want for our CIRCOM circuit. Oh, I should probably show you the CIRCOM circuit. Let me bring that up first. So this is just some CIRCOM code. I'm not going to go through it in detail, but you're welcome to do so in our repo. This actually was my developer onboarding project a few months ago, so I'm on the other side of the computer for it now. But the CIRCOM circuit was compiled into these artifacts. There's some WASM and a Z key, which are used for verification. And then this circuit.json is what we import into the code itself and lets us generate the witness for the proofs. These are important, particularly these two have to be downloaded or included in any client or server that needs to actually verify proofs. Those are available on the ZooPass server and downloaded to the ZooPass client. Okay, back into the PCD. How am I doing on time? I think we're good. All right, so we've formatted the inputs that are required by that circuit. There's a little bit of awkward converting of numbers between different formats. I won't go into that code in detail right now because it would take a while, but happy to talk about it later. And then we just ask Groth16 to generate a proof for us. Here you can see that WASM and that ZKey file that were generated as artifacts. And then the last thing we do is we take the output of that proof and we use it to generate our claims. This is the point where the logic in the proof actually specifies which things get revealed and which don't. We could have derived that from the inputs directly as well, but just it felt a little bit cleaner to make sure that they're always going to match the proof because we're taking them from the proof outputs. But there is a bypass in that logic I just described, and that, remember, the public signals contain, for instance, a hash of your email, not the actual email, because that's what's being signed. So when we see that, we take the output of the proof, and we grab the actual email and put it in the claim, so it's useful. But the proof decides whether we do that or not, whether it's revealed or not. The verify function is very similar in reverse. See, we're again doing the two important steps. The second one is verifying the proof itself is valid. That's just a bunch of numbers doing a bunch of math. The other thing we're doing is checking that our claim actually matches what's in the proof. And we do that by regenerating the public signals that go into the proof. We could have saved some time if you're doing prove and verify on the same machine by saving it, or like saving it in the PCD and serializing it. But that would have let people play games by messing with the claims. And if the claims don't match the proof, then the claims aren't useful. So that's what we're doing here. There is an important third step that isn't in this code because it's what a user of this code has to do, which is once a PCD has verified that it's valid, you do have to check that those claims are whatever your app actually wants. An example is when a third-party app gets, like our Telegram, gets that proof that you have a ticket, one of the public outputs of that proof is who signed the ticket. It's very easy to generate a ticket signed by a key that I just made up, but in order to check into and get into the Devconnect conferences, you need to prove that you have a ticket that is signed by the correct issuer, which in this case is the ZooPass server. So that the fact that a PCD verifies doesn't necessarily mean it's the PCD you want. If you're going to use it, there's an extra level of like checking that the claims are the thing that you actually want to be proven. All right, back to the slides. Plenty of time. So that's kind of the walkthrough of the code. I want to talk to you a little bit more about specific use cases and examples that you can use if you want to learn how to work with some of this stuff. I'm not going to go deep into the code for each of these, but just talk to you a little bit. One of these examples that's out there is called ZooAuth. This is an example of ticket-based authentication, which is what the Telegram is doing. It's in a form what the people who check you in at the door are doing, though they're not doing it online, they're doing it with a QR code. This is a live repo. You can go grab it, and it shows you how to integrate this PCD package make that request that Ivan showed you a demo of, and then use it to log into a website and how you might go about doing that. There are already several live examples of people who did the hackathon back at Devconnect, which was the last couple of weeks, who have built on this. You can go grab use a faucet to get some ETH on the Holsky testnet if that's something that you're into, and they'll validate your ZooPass that you have a ticket to Devconnect and give you some of that test ETH. I did that. It was useful for a project last week. So check out this repo. There's going to be a link to it in our big bunch of links at the end if you want to do the authentication use case. The other example repo we have out there is an example of how to issue your own tickets. This one is built by Rob. It's in his GitHub, linked here. You can issue your own tickets that follow the EDDSA ticket PCD format. You can do whatever you want with things like the event ID, the ticket ID, et cetera, whatever you think is meaningful to you. You can put a picture in them instead of a QR code. All that is in there. You can find it in the code. And then, of course, you're going to sign it by your own public key, which means that You can't create tickets to Devconnect for your friends who maybe didn't get in the door, but you can create tickets to a side event or something in the future, or you can create things that aren't really tickets but are, use the same mechanisms if you just want to be able to pass out, passes or verifiable things. It's a useful pattern that may be reusable. So check this out, and then users can just have a URL, plug it into their ZooPass app, and that point it at your server, and they'll get whatever tickets you choose to issue to them. The last example I want to talk about is PROGCRYPTO. A lot of you have probably been collecting frogs this week. I've been excited by how many people are into it. It is basically an extension of the same pattern I just showed you. There's a EDDSA signed message at the low end. There's an EDDSA frog PCD, which is almost exactly like a ticket, just has different fields. The fields are the frog stats, the URL of the image, and like a ticket, it is tied to your semaphore ID, which means that the frogs are not transferable to your friends, sorry. But you can make proofs about them and do things with them. We have a ZK EDDSA frog proof PCD in the repo. It's being used for some things that are rolling out today and tomorrow that people will be able to do with their frogs, so look forward to that. But it all is really an instantiation of the same pattern that you just saw. It's the kind of thing that you can do with a custom PCD package if you want to build one, and then a custom issuing server. It's also a demonstration of a lot of the app side customization that we'd like to make easier for more people to do. Forrest, who worked on this, has written a lot of custom client-side code inside of the ZooPass app itself to make PROGCRYPTO beautiful and delightful. We'd like it to be easier for third parties to do that without working directly in our repo. We're not quite there yet, but that's the vision of the future, and PROGCRYPTO is meant to kind of show off what it could be. All right, 15 minutes left. So the last thing I want to do is shift from kind of developer onboarding into maybe talking to you about the roadmap and what the team is working on next that you can help us with. So in two sections, one of this is like, what do we want to do to make this more of a robust system, more of a real system that can stand the test of time and people can build things on top of? There definitely are some things we've learned from Devconnect, or things that we knew we had as shortcomings just because we've been building this very quickly, trying to get a proof of concept out there. The syncing system, which Ivan referred to very briefly, sends your data between your different devices via a encrypted server. Everything is encrypted on the client side. That makes it a little bit difficult to deal with conflicts if you've got multiple clients in different states. We do our best, but conflicts happen. People have lost a couple frogs this week, unfortunately. I'm very sorry about that. Since I built the syncing system, I'm going to make it better. With that in mind, though, we also want to build kind of the ability to export, import, backup, and restore your PCDs in case, so you can make sure you don't lose anything when they've got things in there that are important to you and not just going to be reissued the way that your tickets are. That's very important. We want that storage API to be pluggable, somewhere you could just choose where your PCDs get stored. You could save them to a file, you could put them in your Dropbox, you could host your own server. Like, that's the intent. The storage API is very generic, just needs some bytes in, bytes out. We think that probably a better experience for a lot of people would be to have native mobile apps rather than a web app. Web app has been great for moving fast and getting it out there quickly, but watching people stand there in line waiting to check in while their web app loads, even if it's for like 5 or 6 seconds, has been painful to me. I think we can do better in the future. And then, like, as I mentioned, backward compatibility of and versioning and standardization of the PCD formats is something that we're going to have to think about over time. Other future work related to extensibility. As Ivan mentioned, we want to make those PCD package more pluggable so that you don't have to actually send us a PR in our repo. We will review those PRs if you want to, but we want to make it possible for that to be something that people can build on without our permission. We want to separate the PCD logic from the rendering in the app. Right now, I showed you that the PCD package has a couple functions in it that are related to how the app renders that QR code. I personally think that belongs in a different layer. We can separate that out. We want to have, as I mentioned, the ability to plug more things into the client so you can build experiences like PROGCRYPTO that are kind of heavier client-side experiences than just showing a QR code. And some other kind of more future things is being more flexible about how do you query across apps to ask for, give me a PCD that matches this set of constraints. or this set of requirements. We've got a version of that for the ticket. You saw the drop down where you can pick your ticket, and we will filter it down to tickets that meet the constraints, but it's very specific to tickets. We'd like to have a more flexible query language, maybe even a way that you can customize, like, please make me a proof about these 4 PCDs that you have, and combine that together dynamically. And standardizing all the formats and protocols would make that much easier. Yeah, that's what I've got. This is the promised QR code. All of the QR code and both of those links go to the same place. It's just a Notion doc that has a bunch of links in it. So please check it out in whatever format you like. And we have about 12 minutes left for Q&A and discussion. So yeah, please let me know what more we can tell you. Like that. Do we have the mic?
Oh, thank you for your talk. So yeah, regarding standardizing formats, right now the claim for like the ZK proof is really sort of tailored to that circuit, and the claim for the EDDSA signature probably just looks like really specific to EDDSA. And yeah, I would be curious to get a preview into how you're thinking about standardizing. Is it like ZK-JSON? You need some like universal way to parse these claims. Yeah, so what are some options you're considering?
I think it's still a little bit too open. Ivan can tell me if he has more to say. Like we don't really have a plan. We have a set of requirements and things that we want to do. I think that it at some level, it's more of a protocol question than it is a ZK or cryptography question. Because what you really want to express in like a query language or a request for claims or a set of claims is, here's what this thing can do, and then the logic of how you validate that is separate. They need to be tied together, but I don't think that the claims themselves have to be in a ZK validated language, for instance. There just has to be that verify function that can tie them together. Yeah, so I don't think I have a full answer to you. It's not thought out so much, but it's something that we're definitely going to be thinking about in the future.
Very hard problem, like harder than writing a ZK circuit.
I think the end game is going to be like a ZK VM.
To flesh that out a bit for anyone who hasn't heard the term before, the idea being that the request or claim is itself executable code, I think is what Ivan is getting at. So that what you're doing is like specifying what would you like me to prove as a set of code that we run inside of a circuit or in a ZK provable way. I do think that'll get us there in the most general case, but that's a little bit farther out to get that right. It is a hard problem, as you say. I think there's a question over here. Can you pass the mic over? I think they're going to be recordings, so hopefully people can hear the questions.
Yeah, I think this question comes a bit in the same, following the previous question, has to do with a lot of these things actually remind me of verifiable credentials and anonymous credentials and stuff like that. What are your thoughts on how these things relate to each other, and what's the difference, and why would I use PDCs and PCDs instead of VCs, for example?
I think the intent of the PCD concept is to be general enough to contain all of these things. So a PCD is a piece of proof carrying data. It's meant to be data that is self-evident. We're not opinionated on which particular cryptography or which particular technologies, or even really which particular format you use to represent that. We use semaphore for our core identity in ZooPass, and then tie it into the proofs and the tickets and such as I showed you. So I think my answer is that it's not that ZooPass is an alternative to that. ZooPass is a way of managing those types of identities. So in theory, you could be using ZooPass or something like it to store different types of identity credentials, and then generating a proof based on one or more of them, depending on whatever is needed. Right now, we see all of the specific credentials and the specific PCDs in there as examples that meet our current use cases more than they are like the be all and end all of this will be your one true identity forever.
To add a little bit of color, we don't really look at verifiable credentials or DIDs or very many other examples of systems that look like this when we develop ZooPass. I think where we're coming from is we want to make use of ZK so far and maybe other programmable cryptography in like interesting ways. And we're trying to do that as quickly as possible. And so we're working backwards from that. And what has emerged is this PCD SDK.
Thanks.
Hi, I have two questions. Is portability of these PCDs possible today? What I mean by that is when I have a ZooPass account, it's currently connected to my email address, which has a list of PCDs. Is it possible to port these PCDs into a different account? That's the first bit. And the second one would be, a lot of the use cases that we talked here could be applied in a sort of Web 2 world or a Web 3 world too, but most of the applications or demo applications that have been built were catered towards the Web 3 sort of use case. Have you also been thinking about this from a Web 2 usage perspective? And if so, what are your thoughts there?
Regarding the first question, the PCDs are portable. They're just JSONs. You can export them from your local storage. One caveat to that is many of them are going to be watermarked in a permanent way to your particular identity, your semaphore identity, which is one of the PCDs that you are able to export, but you wouldn't be able to associate them with a different account. In terms of Web 2, Web 3 use case stuff, personally, I don't really like Web 2 or Web 3 as terms, so that's not like a native way for me to think about stuff. Trying to like translate my thoughts into Web 2, Web 3. I would say like where we're coming from with these use cases is we wanted to have low stakes experimentation playground vibes. So that's why we have frogs and tickets and not money. But I don't know if you were there during Brian's presentation. One of the examples he frequently brought up is like disintermediating credit score such that you would be able to prove your financial credibility without having to rely on Daddy Equifax or whatever. So I think we do think this technology can do more real stuff, whether in Web 2 or Web 3. We're not there yet. I don't know if that answers your question or if it's in the same direction as how you're thinking.
Yeah, I mean, I get the sense of how you think about it. Yeah, thank you.
I can throw my version of that out, just if it's helpful. I think that this PCD concept is something that is a little bit orthogonal to Web 2 or Web 3. It can work with both, but it also has the potential to supplant both in a lot of cases. So maybe it's not quite orthogonal in that sense. But like Brian has said in his talk, of the ability that you can prove who you are without relying on Facebook, and you can prove your credit score without relying on Equifax, like that kind of is a Web 0 maybe like use case. Like there's no web server involved at all. There is an internet involved in that. That's how you're communicating with someone, unless you're using QR codes or something, I guess, which is off the internet. But the idea is that this is giving, one of the things I like about this vision is it's giving users more control over their data and their identity and their kind of the cryptographic secrets that they own. They don't need to rely on a trusted server. They don't need to rely on a blockchain either. both of those are powerful and will have their use cases. I mean, the Telegram group that you join using our PCD is a Web 2 technology, and there's, the Holsky ETH faucet is a Web 3 technology, and we want this to be able to plug into all of those things. And we actually put a lot of work when writing the CIRCOM circuit for the ticket proof into making sure it was manageable in size so it could actually be verified on chain. Otherwise, we could have had, far more features and not been as worried about how long that list of event IDs was, for instance. So those are things that are on our mind, but we're looking for generality right now. Other questions? Back there, can you pass the mic over, please?
So my question is not as big as the other ones. It was just in one of the PCDs, I think the ticket PCDs, there was a field which was I don't know, it was revoked or not revoked, one of the two. Mm-hmm. So what is actually going on there? Is what, say I've got this non-revoked ticket, right? And I've also got a revoked ticket. I'm not really incentivized to show my revoked ticket if I've already got the other one. So mm-hmm. Is there this nullifier set being recorded somewhere else? Is the person who issued this able to nullify that old ticket which says that it's not revoked, and then they issue me this new one which is revoked, which I can show for whatever reason? I don't know why I'd want to show a revoked ticket, but yeah. Yeah,
that's an excellent point. The mechanics of that are a little bit specific to the Devconnect use case, though there are idealized versions of that you could build. The answer in the normal case is if your ticket is revoked or consumed or those things change, the next time you poll your feed server, it'll give you a new ticket which will replace the old one. Of course, if you bypass the client code or if you saved an old copy of the PCD, you can keep the non-revoked one, and that's why it's up to the ticket scanner, which is also in the ZooPass app that we didn't really talk about, to decide what are the requirements to make you meet in order to actually get into the event. And in the case of Devconnect, there is a super user status that is actually checking the status of your ticket on the pre-tick server. So if it's revoked, it won't. We will show that in the app, but if you showed the old one and it's out of date, they will find out because they actually ping the server. So that's something that's not purely PCD based and is a bit of a ward in the system in that way, but that's the easiest way to deal with that. The other thing that you could do slightly differently, and that we did something closer to this at Zuzulu, or at ZooConnect last week, is tie the proofs and the ticket display to a timestamp, and say that you won't, if the scanner won't accept a ticket proof that was generated longer ago than a certain amount of time, then you keep you from reusing your pre-revocation ticket. It's not in the QR codes, but something you could build is use the watermark and the nullifier to avoid, taking the same ticket more than once or accepting a ticket that wasn't generated specifically for this interaction in an interactive way. We do use nullifiers in the Telegram integration. That's how ZooRat makes sure that you can't post more than 3 times a day. It's because you're actually generating a nullifier despite the fact that you're otherwise anonymous. So all those are possibilities that are kind of buildable with this. It depends what the clients do with it.
Thank you very much. So it's not totally disintermediated, but it kind of is depending on how you do stuff. Yeah, it can be depending on what your requirements are. It's up to the client to decide what those requirements are. And in the case of Devconnect, we really wanted them to use this, and they were very open to using it, but their requirements were not easily buildable in a perfectly disintermediated way because, we're also not taking your credit card and selling you your ticket. It's not, there's another server that does that. Thank you. Anything else? I think we're out of time, but no one else is going to kick us out. I think we're in the last session. So if there are more questions, go ahead. Otherwise, we'll hang out and can talk for a bit. All right. Thank you all for coming.